We're at the booth of Eulitha, and Eulitha is doing lithography machines for photonics. And we're here with Jason. Hey Jason,
Hello.
Please introduce yourself and the company.
Hello everyone, I'm Jason from Eulitha, Switzerland. I'm the team head of computational lithography in our company. I'm very glad today to introduce our technology and our company.
Awesome. So lithography, what is lithography used for in AR?
Well, lithography is in AR, it can be used for making this very high resolution diffraction grating waveguides.
Yeah, we love the waveguides in the very thin smart glasses. I think not many people know how waveguides are made.
Yes, there are different ways to make these waveguides on the wafer. There's nanoimprint and there is also lithography. Because nowadays many customers want to have very high performance. They want to have gratings etched into the waveguide, and that makes lithography really competitive because lithography and etching, they are basically born together. They have been. It is a very mature process in the semiconductor industry.
Yeah.
And it always works. It's very solid, very stable.
Interesting. So this etching, this is something that some companies are now more interested in, because I think from what I've heard, the image quality may be better, right? And you would say it's like the performance. Performance, yeah.
Yes.
What does performance mean?
For example, take an extreme example, many customers, they want to have an extremely large field of view. They want to have high index substrates, maybe high index glass or even silicon carbide. And to make the most use of these materials, make the most use of the power, then etching them into this, etching the gratings, the waveguides into this substrate would be necessary, or at least advantageous.
Yeah. So we've seen at other booths, we've seen waveguides with etching from North Ocean Photonics, from Gore-Tex. And so what other companies are working on this etching process?
I think almost every of these waveguide companies I see also at SCLE, they are all showing. This is really a trend, I think, in the community, in the industry, that because this just works better.
Yeah. And would you say it works better now, and it's maybe a pathway if silicon carbide becomes a thing, and for that you need etching, right?
Yes. But that's not only silicon carbide, even high index glass.
Yeah.
Also, I think etching also performs better than.
Yeah. High index glass is made by companies like Schott and Hoya and these types of companies, right?
Yeah, that can be. I'm not the expert on the substrate material, but yes, I think so.
Yeah. And so you can make the waveguides less expensive, right, with your technology.
And better.
And better.
Yes.
Yeah.
With our technology, we are able to make waveguides cheaper, or for the same cost, we make much better waveguides. This is what we enable.
Yeah. Your machines, they are different from what... They are somehow new, right? They're a little bit different than the typical nanoimprint machines.
They are different from nanoimprint machines. They're also different from conventional projection lithography machines or mask aligners. Our technology, DTL, has very unique advantages. It has an unlimited depth of focus up to more than 1 millimeter. This is more than 1,000 times than projection. It also has an extremely large field of exposure. We can expose a 6-inch wafer in one exposure, all patterns together. So what you see here on this wafer, all these big gratings in all these 4 pieces, they are exposed in one exposure.
Yeah.
This is never imaginable before, I think.
Yeah. So you save time, basically, right?
Yes, we save time, but also it comes with a very high resolution and quality and uniformity, because everything is done all together. You don't need to step and repeat. You don't need to stitch.
Yeah.
Because we are a lithography technology, it works with the industry standard mature photo mask, a photoresist. It's just a DTL is just a different way of imaging.
Yeah.
But in addition to that, all these upper and lower chains, the process flow, this is really standard and it is mature in the semiconductor industry.
Yeah.
So it's a very reliable process.
Yeah. What's the hurdle of adoption? So they have to invest in new machines and they have to learn how to operate them.
I think what we need to work is just we need more people to know us, right?
Yeah.
Many people they knew maybe nanoimprint or other technologies earlier, but we are a newcomer. That's why we really want to show our strengths and capability in this market because we believe we are the lithography solutions that is really uniquely advantageous for AR applications.
Yeah.
Actually, maybe I can also show you here. So here, this is a big HUD device, and this we have such a large area of gratings. Maybe difficult to be seen here, but this huge grating, this is also exposed in one exposure without stitching, and that makes a big difference.
Yeah. So what is this used for?
HUD can be used, for example, for it can maybe put in the helmet for specific applications, or put in the cars, or even put for other alternative displays, future kinds of displays.
Yeah. This is custom large area waveguides.
Yes. It is. So the eye box here is 80 by 20 millimeter square.
Yeah.
And without stitching, this is really unique. This is really a unique strength that we can do.
Yeah. But AR waveguides probably in the next few years the biggest market, right?
I think so.
Yeah.
We are very optimistic about this market.
Yeah. Hey, nice to meet you. Please introduce yourself.
Nice to meet you, Norman. My name is Harun. I'm a researcher by training. I have worked in lithography generally, starting at synchrotrons, doing EUV lithography. Did some leading work on EUV lithography, doing very small stuff like less than 10 nanometer things. But then developed some technologies in Switzerland at synchrotron facilities, and we transferred this technology from synchrotron to more practical light sources like lasers, and developed really unique lithography systems. And then these are especially for making periodic structures, which is good for photonics applications. AR is a huge application for us. Basically, we can print AR waveguides, diffraction optics at lower cost than anyone else, and with higher quality. And it's optical lithography, so there's no contact. We are totally relying on semiconductor industry for materials, for processes, for methods. So it's very easy for the industry to adapt. We use the same photomask as them, same photoresist. So it's very easy technology. Our technology is also used for other applications like VCSELs, DFB lasers, you name it. It is really an exciting thing to do, personally. We have now, our headquarters is in Switzerland, but we have branches in US, and we just set up a lab in Beijing. I'm very happy with
So how many machines can you make? Or how many customers do you have, let's say?
Basically, I cannot give you an exact number, but we have delivered close to 100 systems. A good number of them is in China, and many others in the US and Europe. Also in other countries in Asia, we have systems, yes. Yeah.
And we're here at CIOE. What can you tell us about CIOE? Have you been here before, and what's your experience?
Yeah, we have been here before. We have, again, we have our own company in Beijing. Our colleagues set this up for us. No, it's a great place. It's huge, and the important thing for us is that we can meet our customers here.
Yeah.
And they are all in one place together, and we can meet them at the right level here. It's amazing, actually.
Awesome.
Yes.
Thank you so much for having us today.
Okay, thank you.
Thanks for the interview.
Yeah.